Hi there. So in this video, I'm going to be honest, this is just going to be more practice with integration by parts. I don't really have many new things to teach. It's just good to kind of practice as much as you can. I'm kind of going to try and guide you through some of these harder questions. So this video is just going to be one question long, but it's going to be a bit of a longer question than the one after this will definitely be, it'll be a bit of work. So this is kind of an introduction to the hardest you can get in terms or for our purposes right now. Okay, so let's take the integral of e to the x sine x dx. So remember our acronym LIATE. We got to look for logs, inverse trig, algebraic, trigonometric, exponential. Okay, do we have any logs? Nope. Do we have any inverse trigs? Nope. Any algebraic? Nope. Any trig? Yes. Yes, we do. So remember, whatever comes first, that's your u. Okay, so our u is going to be sine x. Du, obviously just cos x dx. Okay, v is going to be whatever's left. So the integral of e to the x. So we already did the sine x. Integral of e to the x dx, which is just e to the x. And then dv, e to the x dx. Okay, we've kind of set it up. Now let's plug it into our formula here. So I'm not going to write out the actual formula because I think we've done it a few times here, but it's going to be the integral of u dv, so sine x e to the x dx equals u times v, so e to the x sine x minus the integral of v du, so e to the x cos x dx. Cos x dx. Okay, so we always kind of look to see if this second integral is getting any harder than what we started with. It might not be getting easier, but as long as it's not getting harder, we're going to kind of be able to trek onwards here. So I'm not going to write out, actually, yes, I will. I'm just going to write it a bit smaller. Integral sine x e to the x dx equals, okay, e to the x sine x, no integral there, we're going to leave that as it is. Okay, and then we're left with this minus integral e to the x cos x dx. Okay, so for this guy here, or girl, or whatever, I'm going to say let u equal cos x, right? Because that's our t, our trigonometric function. It comes before the exponentials for u. t equals negative sine x. Okay, so if we're differentiating cos x, remember that's going to be negative sine x. dv is going to be, dv will be e to the x dx, right? And then v is just going to be e to the x because we're integrating dv to get v, right? Integral of e to the x is e to the x. So we're going to subtract, I'm going to write it a little lower quickly here. du is negative sine x dx. Right, just so I don't forget, I'm going to write dv equals e to the x dx. V equals e to the x. Okay, I'm just going to plug that in there. So we're subtracting the integral, right? We're subtracting the integral of e to the x cos x dx. Instead of writing that integral, I'm going to write its alternate form from integration by parts. So we're going to be subtracting. That integral is going to be the same as u times v minus the integral of v du, right? So u times v is just e to the x cos x minus the integral of v du. So v is e to the x, du is negative sine x dx. So negative e to the x sine x dx. Okay. Now let's think how we can kind of simplify this. We're subtracting a negative inside the integrand. So anytime that happens, we can just kind of cross those out and make it a positive. So we're adding the positive integral of e to the x sine x dx. Okay, I'm going to get rid of the stuff below it. Okay, just kind of close off the bracket there. All right, so let's see how we can kind of solve this now. So see how we started with the integral of sine x e to the x, and on the right side we ended up with the exact same thing. So you might be thinking, well, that was pointless. Like, we did all this work just to get the same thing on the right side. And actually, that's exactly what we want. Because if you have two things on opposite sides of an equation, those are like terms. So we can take this integral and move it over to the left side. So first, I'm going to distribute this negative. Okay, so it's going to be minus e to the x cos x minus, I'm going to write minus e to the x sine x. Or, no, it's going to be, hold on. No, why'd I erase it? Why'd I erase it? E to the x cos x, so it's going to be, let me just think here. I can't go back now. So u, we said, was cos x, so du was negative sine, and then v would have been, okay, so it would have been negative e to the x cos x. Negative e to the x cos x. And then we're subtracting the thing that we had on the left, right? So it was minus the integral of sine x e to the x dx. All of you can kind of go back in the seek bar, but I couldn't, right? It wouldn't let me go back, so I had to kind of redo it there. So right now, this is what we have. Like I said, if we have two things on both sides of the equation, we can just add this on both sides. So we can add the integral of sine x e to the x dx. Even though it's what we started with, it wasn't for nothing, because now it's gone on the right side. Okay, so if we had one of them before and we added it on both sides, now we're just going to have two of them. 2 times the integral of sine x e to the x dx. And since it's gone on the left now, we're left with e to the x sine x minus e to the x cos x. Okay, and we could factor this right side, right? We could say this was e to the x times sine x minus cos x. Like I said, it doesn't matter. The main thing is we got rid of that integral. It's on the left side. So to solve for just one of these integrals, right now we have 2 times the integral sine x e to the x dx. We just divide everything by 2. So our original question was saying, what's the integral of sine x e to the x dx? Our answer is going to be a half of, I'm actually going to factor it out. I like it factored. So a half of e to the x sine x minus cos x. And don't forget that plus c at the very end. Okay, so this question a little bit trickier, but it forced us to think of this as an equation rather than an expression. Because so often we only focus on the right side of integration by parts that we forget that it's an equation. And anytime we get the same thing on the left and on the right, we can get rid of this integral on the right by just adding it or subtracting it on both sides. Okay, and then it's just gone. It joins the left side, and we can just divide by whatever this coefficient is. Okay, and you're left with just one of those integrals and that's going to equal whatever you had on the right divided by that coefficient. So it's super helpful to think of it in terms of an equation. And I hope this example was kind of not easy to follow along, but you were able to kind of follow along and apply it into other situations in our next videos as well. So the next video, it's going to be probably about 2 or 3 times this length. This one wasn't too bad, but it's going to be my last video on integration by parts, so I'm really going to make it a tough one. So if you can get through that one, then you're going to be good to go. I hope this video was helpful. I'll see you in the next one where we tackle one of the harder possible integration by parts problems.